Okay, so next up is the derivatives of a to the x, so a base that is not e in an exponential function, and a log base a of x, so logarithms with a base that's not e. These follow the exact same forms as our original e to the x and natural log x, so let's refresh our memories on those. The derivative of e to the x is e to the x. So that's really easy to remember. The derivative of the natural log, log base e, of x is 1 over x. So those are some of our common derivatives. Okay. Then we're going to look down, and I'm going to start with the log base a of x, because it's got the simplest explanation. The derivative of a log base a, so something that is not e, could be 2, could be 3, could be 17, doesn't know, but of x, is 1 over x with an extra natural log of a at the bottom. The reason is here. So recall, our original functions, the natural base, e to the x, natural log of x, very simple forms. So the idea for handling these non-natural base equations is to change them into the natural base and go from there. So for the logarithms, log base a of x, using the change of base formula from algebra 2 in pre-calculus, we end up with the natural log of x divided by the natural log of a, splitting off the value and the base. And then we can just differentiate that, because the natural log of a is a constant. We effectively just get to ignore it. It carries through the derivative. So the derivative of the natural log of x over the natural log of a is just the derivative of the natural log of x, 1 over x, and then we carry that constant natural log of a through. So we get that very simple form for that one as well. For our exponential functions with a base that is not e, so 2 to the x, 17.39 to the x, whatever you want, we end up with a to the x and the natural log of a. So very similar to this. Okay. Repeats the exponential function and tacks on a natural log of the base of that exponential function. So if we had 3 to the x, its derivative would be 3 to the x times the natural log of 3. Really for the same reason as the log base a, because we're going to change it to the natural base. It's just a little bit more complex. So a to the x can be written as e to the natural log of a to the x, keeping in mind that e and the natural log would cancel each other out and just leave that a to the x. Then, by the power property of logarithms, I can use that to bring x down. So now I can rewrite a to the x as e to the x times the natural log of a, which has that natural base that I'm looking for. So we're going to differentiate that. Differentiate that expression, e to the x times natural log of a, using chain rule, which by that definition, we take the derivative of the first, e to the x, at the original inside function, x natural log a, and then we multiply that by the derivative of that inside function, x natural log a, which would just be the natural log of a by power rule. So now we have this. And then, because e to the x natural log a is equal to a to the x, I undo that substitution, get a to the x, and then that natural log a follows through. So we have those two. That is the next exercise. From there, you have the chain rule capstone, and then a quiz, which acts like a skill, so like one of the concept questions on the grade book. And then next week, we'll start with the videos going over implicit differentiation, second order differential differentiation, etc. Okay. I am working on your derivatives test. It will be up soon. I'll probably get all that up next week for you guys so you can just get it out of the way and done. It'll be about 10 problems on derivatives, just the stuff you've covered. So power rule, product rule, quotient rule, chain rule, and a few common derivatives, sine, cosine, tangent, stuff like that. Probably multiple choice. Makes it easier for me. But that's it. So just work on that. Again, don't take it too seriously. Don't stress yourselves out. This shouldn't take you too long. If you are finding that it's taking you longer, email me. I can help out. Maybe if you need something else posted on a video, just email me and I will do that. But otherwise, just get working on that. And again, as soon as you're done with all the stuff that is on Google Classroom and Khan Academy, including the 3 quizzes that I will have posted soon and the Great Calculus Caper, you are done. Bye, guys.